Good morning, students. Today's class we are going to study about a design of ideal band pass filter whose frequency response here it is given by hg of e power j omega equal to 1 for pi by 4 less than or equal to modulus of omega less than or equal to 3 pi by 4 0 otherwise. You need to find out the values of h of n for n equal to 11 and plot the frequency response. So first step is you know that according to the given problem, it is modulus of omega. That means the omega has positive value as well as negative value. So when it is having a positive value, the limit will be pi by 4 to 3 pi by 4. When it is having the negative value, it will be from minus 3 pi by 4 to minus pi by 4. Okay, so according to that, the HG of n, the inverse Fourier transform is applied over here. So the inverse Fourier transform is HG of n equal to 1 by 2 pi integral over minus pi to pi HG of e power j omega into e power j omega n. Now, in this, according to this limits, we have two limits. One is minus 3 pi by 4 to minus pi by 4. Another one is pi by 4 to 3 pi by 4. So we have to integrate it and substitute the upper and lower limit. After that, you will be getting the expression as 1 by pi n of sine pi by 4 pi 3 pi sine of 3 pi by 4 n minus sine of pi by 4 n. So where n varies between minus infinity to infinity. So you will be getting some expression for hg of n. So you have to truncate the hg of n to 11 samples because n equal to 11 according to the given problem. So now h of n is equal to hg of n for modulus of n less than or equal to 5. How we are getting the 5? Because modulus of n less than or equal to n minus 1 by 2. Capital N is 11 minus 1 divided by 2. It is 11 minus 1, 10 divided by 2, which is 5. So it is equal to 0 otherwise. Now we have to find out the coefficient of h of 0, 1 till 5. For h of 0, if you integrate, just integrate that 2 with respect to d omega, we will be getting the answer as 0.5. Then for other values of n equal to 1 to 5, we have to substitute here n equal to 1 to 5. We have to use this formula and substitute here. So you have to keep it in mind. You have to use your calculator in radian mode to find out these values. Okay, so now keep your calculator in radian mode and then start calculate the values for h of n, which is equivalent to 0. H of 2 you will be getting minus 0.3183. H of 3, H of 4 and H of 5 you will be getting the value as 0. Then the next step is we need to apply the transfer function of the filter. So the formula is h of z equal to h of 0 plus summation n equal to 1 to n minus 1 by 2 h of n z power n plus z power minus n. So now in the place of h of 0 will be substituting it as 0.5 and in the place of h of n we have to vary n equal to 1 to n minus 1 by 2. So here n equal to 1 to 5. So before expanding it, you can able to see that all the h of values are 0. So only h of 2 has the value. So we'll be taking that alone. So minus 0.3183 of z power 2 plus z power minus 2. So you'll be getting a simplified transfer function. Then after that, you have to apply the transfer function of realizable filter by multiplying the h of z expression with z power minus 5. So when you multiply with z power minus 5 throughout this equation, you will be getting minus 0.3183 z power minus 3 because z power minus 5 into z power 2 it is z power minus 3 plus 0.5 into z power minus 5 minus 0.3183 into z power minus z power minus 5 into z power minus 2 is z power minus 7. So you will be getting this expression. So from this we have the filter coefficients. So only for h of 3, h of 5, h of 7 you have the value. Remaining places are zeros. So h of 3 according to the symmetrical property h of 3 it is equivalent to h of 7. So that's why the value is minus 0.3183 and h of 5 is equal to zero point 0.5. So remaining values h of 0, h of 10, 1, 9, 2, 8, 4, 6, it is 0 only. Okay, so after that we have to apply in the magnitude function, which is given by the formula summation n equal to 1 to n minus 1 by 2 a of n cos omega n. So in that, to find out the a of 0, we have the formula h of n minus 1 by 2. To find out a of n, we have the formula 2 into h of n minus 1 by 2 minus n. So now if you see, substitute the n value here, it will be getting h of 5, which is equal to zero point 0.5. Then here in the a of n, you have to substitute the values here. So only for a of 2, 2 into h of 3, you will be getting the value as minus 0.6366. So when you substitute the value here, h of e power j omega equal to zero point 0.5 minus 0.6366 cos 2 omega, you will be getting it. After that, you will be substitute omega value will vary from 0 to 180, and find out the h of e power j omega using this formula. So in this formula, you substitute the omega value vary from 0 to 180 and find out h of e power j omega. Then you can use the 20 log of minus 0.1366. You will be getting the values in terms of decibels here. So it is not required that you have to put it in the multiples of 10 like that. So you can put multiples of 30. So you can put the values as 0, 30, 60, 90, 120 and 150 and 190. For these values alone, so you can find out and plot the frequency response. So when you plot the frequency response, you will be getting the band pass filter like this only. Thank you.